Okay folks, in this video we're going to provide an introduction to specification based testing techniques and have a look at the first technique in the list, which is equivalence partitioning. So specification based, otherwise known as black box testing, is all about seeing whether based on a given input if we get the correct output on the other side. So for example, if we specify a valid username and password for a login function and click on the submit button, that we get logged into the system. Likewise, if we specify an invalid username or password and click on submit, that we don't get access to the system. So we're very much focused on the input and the corresponding output, but we don't care about the code execution in the middle, and this is what makes it specification based. So the testers have no knowledge of how the system or component is structured inside the box itself. So in terms of a set of techniques, specification based testing covers both functional and non-functional testing and can be applied at all levels of testing, from component testing right up to acceptance testing in different forms. In terms of this module, we're going to be having a look at 5 different techniques. This video will have a look at equivalence partitioning, and then subsequent videos will work our way through the list of other techniques on the slide we have now. So, in terms of technique number 1, equivalence partitioning, let's just explain what these two terms mean. So starting with the idea of a partition, what we're doing is taking an outcome and separating it into a range of possible groups. So for example, if I had an application that was to determine based on a date of birth whether a customer was under the age of 18 or over the age of 18, there's 2 of my possible partitions already. Based on the date of birth, they are under 18. Or correspondingly they are over 18. So that is 2 possible groups, and they're known as equivalence partitioning. The reason we call it equivalence partitioning is that we take one value in a partition to be representative of all the values in the partition. So let's say based on a given date of birth, we worked out the customer was 15 years of age and that the system correctly didn't sell us alcohol. Well, based on that one test, we would assume that a date of birth given as 9 years of age or 13 years of age or 2 years of age would all act in the same way. So equivalence, we're expecting everything in that partition to be treated in the same way. So that's effectively what these couple of slides state here. So let's have a look at an example. So let's take the requirement based on the overall percentage achieved for an undergraduate degree program. In accordance with the following rules, the degree classification shall be derived and printed to screen. And then we have a list of rules. So this is usually how you'll see this kind of problem presented. So in this case, we identified a number of possible partitions. If we get a grade between 0% and less than 40%, then that's a fail. B between greater than or equal to 40% or less than 50%, it's going to be a third class honours, and we can see similar partitions in C, D and E being developed for a 2-2, 2-1 and a first class honours respectively. Now, A to E define what we call valid partitions. So it's a correct value, it's a positive value that we would expect to get. But we also have invalid partitions to consider as well in this technique. So obviously if we're talking a percentage for an examination paper, we would expect a grade between 0 and 100%. But any grade, if we received one that was less than 0% or greater than 100, then they are classed as invalid partitions, and we need to make sure that an application handles those correctly as well. So, based on those values, what test values would we come up with? Well, it's quite nice to view it in this sort of diagrammatic form. So, as we've mentioned just a moment ago, straight away we have a set of valid partitions and invalid partitions. Our valid partitions all occurring between 0% and 100%, and we have 1, 2, 3, 4, 5 different valid partitions within that range. And then either side we have our invalid partitions. A grade greater than 100 is one invalid partition, and then we have a second invalid partition, which is a percentage of less than 0. So what values could we pick? One value from each partition is quite sufficient. So in terms of our invalid partition test, we got -7 and 104, 19, 46, 53, so on and so forth. The key thing is that we have one value from each partition to prove the rules work. So let's have a look at another exercise here. So take a moment, pause the video and see if you can work out what values you might use here. So, just while you're working that out, I always like to show you what this would look like in terms of some code. So we've said already that we don't care about how the code operates, but if you think about equivalence partitioning testing at a component level, you'll have written in this statement that looks something like this for those insurance rules, and you want to make sure it physically works. Even though you have a knowledge of the code in terms of conducting the tests, it doesn't make a difference. You just need to be able to pick the correct values to actually test. So, rule of thumb, we'll usually go for a value somewhere in the middle. So in this case, I would go for something like this, -2. 6 is somewhere in the middle of 0 and 18. 40 somewhere in the middle of 18 and 65. 73 somewhere in the middle of 65 and 99. And then we have 100 on the opposite side as well. So, little example there, we can take our equivalent partitioning values from a set of rules, written specification as a test basis, or if we're doing something like component testing, which in a development rule you'll certainly be doing, it's been able to have a look at an if statement and work out what values you need to be able to test as well. So, just a few summary points. Partitions can be separated into valid or invalid partitions. Equivalent partitioning is a technique used to achieve input and output coverage, so testing the full range of possible inputs by partition and making sure we get the corresponding outputs. And it can be applied to a number of different input types, such as human input, or we can have different parameters. Again, exactly the nature of the values and how these values are entered will depend on the level of testing currently being carried out. Here we have another example. We're back to the degree classification. We can do equivalent partitioning in different system types. So in the top here we have a simple Java application that calls a method called classify degree, passes it in a value, and we have the corresponding output in the console window, and that's exactly the same from the web-based version we have underneath. So the programming language, the environment doesn't matter. The actual technique is platform and development environment independent. You can still take the same approach in multiple environments. Okay, not going to spend much time having a chat about these. Here are some exercises, so do have a look through the rules, pause the video, and then have a look at the corresponding answers. I'm just going to step through these, but if you do have a question in any of the examples, do drop me an email and we can discuss. Okay, folks, so that is an introduction to structure-based testing and a chat about specification-based testing and a look at the equivalence partitioning methodology. Any questions? Drop me a line. Thank you very much.